Continuing on with our section 9.3 problem, we've got to find a 95% confidence interval for the problem that we just did. Again, as part of the National Health and Nutrition Examination Survey conducted by the Department of Health and Human Services, self-reported heights and measured heights were obtained for females aged 12 to 16. So the table, bear with me, looks like this. We did that in the last example. So I put the equations on here. They look a little scary, especially this one, right? These equations are if you wanted to do it by hand using list 1 and list 2, using the measured and the reported heights. I recommend finding the difference and going from there because it makes it a little bit easier. It's just a standard confidence interval for T statistic. But I did want to put them up here just to show you. So the first thing you have to do is find the pooled variance. You've got n for the first list times the sample standard deviation, and then you would plug it in to that margin of error. That would be your margin of error, the t alpha over 2 times the square root. But I'm going to just do what a standard t interval with this using the calculator. We've done t intervals in chapter 7, so you can go back and look to see how to do that by hand. But let me show you using the calculator. Statistic, we're just going to do a t interval. Our data is still in there from before. I'm using statistics, negative 0.475, standard deviation of 1.98, confidence level, let me verify that as 0.95. That looks good. I'm going to calculate. And it is thinking. Okay, so the t interval, we're saying that the difference in the mean, so mean 1 minus mean 2, does not look like a 1, is going to fall between this, negative 1.734 and 0.7836. So what we just found is that the difference in the means between reported and measured is between negative 1.734 and 0.7836. 95% of the time, if you would ask someone how tall they are and measure them, 95% of the time, your mean differences between the difference would be between those two levels. Now notice that between these two, negative 1.7 to 0.7, contains 0. And what we were testing for, the claim originally, is that there was actually no difference in the means, that people measured and reported pretty much accurately. So this also supports that we should not reject that claim that they're not equal. Now, asking women's weights might be a completely different story, and I will not do a problem on that.